scientists revealed that Jupiter is not what we're being told. Jupiter, the largest planet in our solar system, has long fascinated scientists and stargazers alike. Its massive size, distinct colorful bands, and swirling storms have made it a subject of extensive study. However, recent revelations by a group of scientists have challenged some of the commonly held notions about this gas giant. Their research indicates that Jupiter may not be what we've been led to believe. In this essay, we will explore the alternative perspectives presented by these scientists and delve into the implications of their findings. The hidden core. Traditionally, Jupiter has been described as a gas giant composed mainly of hydrogen and helium. However, the recent research suggests that beneath its thick atmosphere lies a solid core. These scientists proposed that Jupiter has a dense, rocky core with a mass several times that of Earth. This core, hidden from view, may have profound implications for our understanding of the planet's formation and evolution. One of the most intriguing aspects of the recent revelations about Jupiter is the proposition of a hidden core within the planet. Traditionally, Jupiter has been characterized as a gas giant with no solid surface, where the gas gradually transitions into a denser state with increasing depth. However, the research conducted by scientists suggests a different scenario. According to their findings, Jupiter may possess a solid core composed of dense rocks and metals, with a mass several times that of Earth. This proposition challenges the long-standing assumption that gas giants lack a solid core. If confirmed, this discovery would revolutionize our understanding of planetary formation and evolution. The presence of a solid core in Jupiter raises numerous questions about the planet's origins. How did such a massive core form? What role did it play in shaping the planet's overall structure? These inquiries lead scientists to reconsider existing theories and explore alternative mechanisms for the formation of gas giants. The atmospheric composition. Another surprising claim made by these scientists is that the composition of Jupiter's atmosphere may not be as straightforward as we once believed. While it is commonly accepted that the atmosphere is primarily made up of hydrogen and helium, the research team suggests the presence of other elements in significant quantities. These findings challenge the prevailing notion that Jupiter's atmosphere is solely composed of these two gases. Understanding the true composition of Jupiter's atmosphere could shed light on its origins and provide valuable insights into planetary formation processes. The scientists behind this research propose the presence of other elements in significant quantities within Jupiter's atmosphere. This discovery challenges the simplistic understanding of the planet's atmospheric composition and raises questions about the origin and distribution of these additional elements. Understanding the true composition of Jupiter's atmosphere is crucial for comprehending its formation and evolution. It could provide valuable insights into the processes that shape the planet and the mechanisms responsible for its unique atmospheric dynamics. Furthermore, studying the composition of Jupiter's atmosphere could have implications for our understanding of other gas giants in the universe and the prevalence of similar atmospheric conditions in exoplanets. However, it is important to note that further research and observational data are needed to confirm and refine these findings. The complex nature of Jupiter's atmosphere and the challenges of studying a distant and dynamic planet pose significant obstacles in unraveling its true atmospheric composition. Electromagnetic phenomena. Jupiter is known for its intense magnetic field, which is one of the strongest in the solar system. The scientists' research proposes that Jupiter's magnetic field extends far beyond what was previously thought. They suggest that this expansive magnetic field could interact with the innermost moons of Jupiter, affecting their composition and potentially harboring hidden secrets. These electromagnetic phenomena could offer clues about the intricate dynamics at play within the Jovian system. Another fascinating aspect of the recent revelations about Jupiter is the exploration of its electromagnetic phenomena. Jupiter is known to possess a powerful magnetic field, one of the strongest in our solar system. However, the research conducted by scientists suggests that the reach and influence of Jupiter's magnetic field may extend far beyond what was previously understood. The extended magnetic field of Jupiter could have significant implications for the planet's moons and their interactions with the planet. These electromagnetic interactions may affect the composition, dynamics, and even the potential habitability of Jupiter's innermost moons. The hidden secrets within these interactions could unlock a deeper understanding of the complex relationship between Jupiter and its surrounding environment. The presence of an extended magnetic field also poses interesting questions about the formation and maintenance of Jupiter's magnetic field. How is such a powerful and expansive magnetic field generated and sustained within the planet? What role does it play in shaping the planet's magnetosphere and protecting it from the solar wind? Studying the electromagnetic phenomena associated with Jupiter's magnetic field provides valuable insights into the intricate dynamics of the Jovian system. It offers a glimpse into the complex interplay between magnetic fields, charged particles, and celestial bodies, contributing to our broader understanding of planetary magnetism and its influence on the surrounding environment. As our technology and observational capabilities continue to advance, further research and exploration of Jupiter's electromagnetic phenomena will undoubtedly shed more light on these intriguing aspects of the planet and open new avenues for scientific inquiry. Impact on planetary studies. The revelation that Jupiter may have a solid core, a different atmospheric composition, and an extended magnetic field challenges our understanding not only of Jupiter but also of planetary science as a whole. The existing models and theories will need to be revisited and revised to incorporate these new findings. This demonstrates the evolving nature of scientific knowledge as researchers constantly push the boundaries of our understanding. The recent revelations and alternative perspectives about Jupiter have a profound impact on planetary studies as a whole. These groundbreaking discoveries challenge our existing understanding of gas giants and planetary formation, prompting scientists to reevaluate their models and theories. Here are some of the key impacts on planetary studies. Paradigm shift in gas giant understanding. Traditionally, gas giants like Jupiter were thought to lack a solid core, and their atmospheres were considered primarily composed of hydrogen and helium. However, the proposal of a hidden core and the potential presence of other elements in Jupiter's atmosphere revolutionize our understanding of gas giants. This shift in perspective requires scientists to revise their models for gas giant formation and structure, encouraging a re-examination of similar planets beyond our solar system. Insights into planetary formation. Jupiter's hidden core challenges current models of planetary formation. Researchers must now explore alternative mechanisms to explain the existence of such a massive solid core within a gas giant. These insights can lead to a deeper understanding of the early stages of planet formation in our solar system and beyond. Conclusion. The recent revelations made by a group of scientists regarding Jupiter's true nature present a compelling alternative perspective to the conventional wisdom about this gas giant. The presence of a hidden core, the composition of the atmosphere, and the extended magnetic field challenge our long-held assumptions. These findings emphasize the dynamic nature of scientific discovery and the importance of constantly questioning and refining our understanding of the universe. As further research unfolds, we can look forward to unveiling more secrets about Jupiter and deepening our knowledge of the fascinating world beyond Earth.